project presentation. So our project name is Explainable AI Machine Learning for Heart Disease Prediction. My name is Muhammad Usman and my student ID is 77408 764. My supervisor name is Muhammad Shani Khuda. Now we will discuss our first slide. This one is introduction. So our introduction is the first one point is our purpose. And this is our purpose black box means in machine learning to developing the exact output in heart disease prediction. The next one is research focus. We will combine the random forest and SHAP for the accurate predictions. And our aim in this dissertation to develop a machine learning model that predicts the heart disease with high accuracy. So our research objectives to pre-process a data set about heart diseases, basically to construct and evaluate the performance of logistic regression and random forest model for heart disease prediction, and comparison the model of precision, recall, and F1 score to recover the values. Uh, Add the explainable AI to enhance the chef values, and so basically different features of chef attributes and to check the correct interpretability for the decision making process in our research objectives. In our literature review, basically we will have the different key findings. uh, Basically we will have the four key findings: machine learning in healthcare, black box challenge, XAI importance, and ethical concerns. Our methodology slide. So our framework, we will use the cross-industry standard process for the data mining. We will use the Kaggle data set for the heart disease predictions. We will use the 1025 records and 13 features. The next one is pre-processing. We have used the label encoding for the category values and the standard scalar for the numerical features and the different sampling to address the class imbalance to choose the correct positive cases. We will use the different two models, a logistic regression and the random forest. Basically, this logistic regression is the simple model to predict the heart disease, and the random forest is the in-ensemble model to accurate the heart disease prediction. The next one is implementation. We will use the Google Colab and the different libraries, for example, Pandas, Scikit-learn, Chap, Matplotlib, Seaborn, and we will use the different steps in our coding. The first step is the data loading. The next one is EDA, our exploratory data analysis. We will use the different heat maps in our EDA. The next one is feature selection. So, and the next one is model training. In this model training, logistic regression and random forest. So basically, in this model training, 80% training in this logistic regression, and the testing is 20%. The next one is SHAP integration. Uh, Summary for and different dependency plots. For our discussion, some points we will discuss. The first one is achievements, limitations, implications. Achievements: random forest with share with the high achieve accuracy and transparency. They address the black box issue. Uh, and the limitation is the data set lacks demographic diversity and the cost limit for the scalability for the large data sets. And our implication is supports evidence-based some decision making, and GDPR aligned with some transparency requirements. In this slide, our future works, we will have discuss some points. The first one is clinical validation. Uh, they show the some different tests in SHAP in real world in clinical settings. This next one is scalability. Uh, they optimize show the high dimensional data. And the next one is bias mitigation. They will expand the data set to address the underrepresentation, for example, female patients. The next one is interdisciplinary cooperation. They align the SHAP with output, some protocols, and regulatory complements. They develop the framework for dynamic healthcare and real-time deployment. They integrate the model with clinically friendly some interfaces. So now we will explain our code. Basically, we will use explainable AI because they predict every features and they check the hard disease yes or no. Uh, this is our code. So first of all, we will mount the Google Drive, and the next one data loading and processing. These all use the libraries. We can use Pandas NumPy for the data one, and the Matplotlib Seaborn for the visualization, scikit-learn for the modeling, label encoding, and the training, testing, and standard scaler, and the IP widgets for the front end. And the next one, we have load the dataset. So we read the file in the CSV path. So this is our data sets. We have 1025 rows and 14 columns. The next one, we have information about the data set. So we have in this data set, we have all integer value, just one float value. So the missing values is all zero. Exploratory data analysis. Exploratory data analysis means different distribution of data. In the CDA, we have all the numerical values, just like count, mean, minimum, like this one. So the next one is a count. So the next one count plot for the target variable with iterative values. In this count plot, we have two targets. So 0 is equal to no disease and 1 is equal to disease. So in this figure, in the in the blue one is equal to 0 is equal to no disease, and the pink one 1 is equal to disease. So this diagram shows clearly. So the next one count plot for the categorical values. In this count plot, we have shows all the features. For example, count plot of sex by target, count plot of CP by target. So they shows all the features by target. So the blue line shows 0 is equal to no disease, and the pink line 1 is equal to disease. So the next one is distribution plots for the numerical features. And basically, we will have the different distribution plot for the numerical features. Uh, so these all our distribution plots, and they will show the frequency, how up and down, and the different plots in the different features. So the next one is target versus sex. So we have checked the distribution of target versus sex. S means sex 0 is equal to female, 1 is equal to male. So the next one is age versus cholesterol by target. So we have checked the cholesterol level by age. In this graph means age 30 have no cholesterol, 50 to 60 age has cholesterol level too much. So the next one is heart disease versus age distribution. In this graph shows the heart diseases mostly common in 50 to 60 age. So the correlation matrix means a relationship of features, and they check the which features add more values. So the next one is plot correlation with the target variable. So basically in this correlation with target variable, basically in this the blue lines with the up one shows the positive values, and the down one means the bottom one shows the negative values. So the next one is correlation heat map. In this heat map, the red one shows the good values, and the blue one shows the -1, and the central and neutral because they can't affect. And the next one is data preparation for modeling, label encoding to each column. Label encoding means label encode these five categorical columns to basically encode the data. So the next one is define the target variable y and feature x. Feature x drop the values, and the variable y to generate the outputs. So the basically 80% training in this code and 20% testing. So this is the shape of the splits, and the next one is scaling the features. Scaling the features means 0 to 1 value for no issue of data. So the next one is model building and logistic regression. In this logistic regression, we will apply the training, testing, and then we will calculate the accuracy, precision, recall, F1 score. So in this confusion matrix with logistic regression, in the 70 to 96 graph means, and this blocks means to generate the true label means positive values, 9 to 30 means predictive label means the false value. The random forest classifier, the random forest classifier means we will use the training and testing, and then we will calculate the accuracy, precision, recall, F1 score. So, confusion matrix with random forest in this blocks 92 and 102 shows the true label means the positive values, and the 3 and 8 predicted label means the false values. So the next one is models evaluation comparison of model performance. So the comparison of model performance, the two relationships in logistic regression and random forest. So the blue lines means logistic regressions bar, and the green line shows the random forest bar. So the bar shows the good results of the random forest because they will show the high values. Rushi curve, the next one. So the basically in this diagram shows basically the Rushi curve means 0 to 1 value, and if the value is 0.98, so the result is very good. So in this three lines, the logistic regression, random forest, and random guess. Next one, model validation. So this is the model validation, and the five scores of the each fold. So the next one is heart disease prediction example. In this heart disease prediction, so we will check every person's different details, the values of this age, sex, and they will check the heart disease, yes or no. We will use the different details in this bars. Explainability with SHAP. Basically, SHAP is a simple linear model to check the accurate prediction of heart diseases. uh, Plot feature importance comparison. So basically, in this graph shows the comparison of random forest with shape. So the blue line shows the random forest, and the orange one is the shape. So basically, this graph shows the good result of the random forest, and they will show the good values of the random forest. The next one is generate shape summary plot. In this plot, those points expand, which shows the high values, and those points close, so they will be the low values. So generate shape dependent plot for THCH. THCH means maximum heart rate achieved. And this plot shows if the THCH means maximum heart rate. So the if the heart rate is increased, so the CP is also increased. CP means chest pain is also increased. So generate shape decision plot. So in this plot, they can help to generate the decision. For example, CP, THCH as an importance value. So the next one is shape force plot for categorical grouping. So in this graph shows the red one shows the higher values, and the blue one shows the lower values. So the next one is the generate shape force plot for all instances in the test set. So we will check all features in this bar chart. So we will check the uh, slope. So they will show the results in this slope and according to the slope. So we'll check the age. So they will show the results in according to the age. So that's it.